Now children, today let's start with chapter number 2, number system. So in this chapter I will tell you about binary system, number system and conversion from one number system to another and bits and bytes. So let's start with the chapter. You know very well that computer can do calculation very fast, but do you know how? You will learn it by the different machine language, that is 0 and 1, which is the binary language. So let's study about the binary system. So you have already know that computer is a man-made electronic machine. It does not understand language people used to communicate with each other. भाई जैसे हम communicate करते हैं ना, बात करते हैं, तो ये language वो नहीं समझ सकते. So it recognize only discrete states on and off because computer are electronic devices. They are powered by electricity, which also has only two states on or off. Two digits 0 and 1 can easily represent two states. Digit 0 represent electronic state of off, और जो आपकी डिजिट 1 है वो क्या रिप्रेजेंट करते हैं? इलेक्ट्रॉनिक स्टेट ऑन. सो पीपल काउंट एंड दे यूज डिजिट इन द डेसिमल सिस्टम एंड व्हाट अ कंप्यूटर यूजेस बाइनरी सिस्टम बिकॉज इट अंडरस्टैंड ओनली टू स्टेट्स. ठीक है, ये खाली दो स्टेट्स समझता है एंड इट हैज जस्ट टू यूनिक डिजिट 0 and 1 व्हिच इज कॉल्ड बिट. एंड व्हाट इज बिट? इट इज द स्मॉलेस्ट यूनिट ऑफ डाटा. और कंप्यूटर्स को क्या करता है? रिप्रेजेंट करता है, राइट? When 8 bits are grouped together as a unit, they form a byte, and a byte is informative because what it provides different combinations. This is 0 or 1 to represent 256 individual characters, and these characters include number. यहाँ पे आपके नंबर होते हैं, अपर केस होता है, लोअर केस होता है, राइट? एंड पंक्चुएशन मार्क्स and others such as letter of Greek alphabet. Every character in computer like alphabet, number, symbols have a असाइन न्यूमेरिक कोड, और जो कोड्स होते हैं ये वेरी करते हैं. ये 0 to 256 होते हैं और इनको हम ASCII मतलब एडवांस कोड ऑफ इंफॉर्मेशन इंटरचेंज कोड, राइट? देन वी हैव 10 digits that is 0 to 9, right, to use to form a number, and each place in a number have 10 times value that of place. So to form the number index greater than 9, 0 is said to be right of 1 and get 10, and we put 1 of the right of 1 to get 11, and then put 2 to the right of 1 to get 12. After reaching this stage, we have no more digit and we start putting digits 0 to 9, and the right of 2 and get 20, 21, 22, 23 and then till 29. We repeat same process, चाहे वो 3 हो 4 हो, सब में हम same process करते हैं. 31, 32, 33, 41, 42, 43, 45 and still 49. Like this, we have similarities in the binary system also. Like two digits 0 and 1, they are used to form number. Each place in a number has value twice the value. To get the next number, so greater than 1 होता है, we put 0 to the right of 1 and to get 10, and we put 1 to the right of 1 to get 11. As we have no more digit, we put 0 to the right of 10 to get 100, and then we put 1 to the right of 10 to get 101. Right? Again, we have no digit anymore, so put 0 and 1 to the right of the new form number, that is 100, 101, 110 and 111. Right? Then we have number system. So let's study about the number system. A computer is an electronic machine that stores data in coded form or machine readable form. They have to be represented in the form of electronic pulses, and two pulses that are used to represent basic number, that is 0 and 1. They are absence of pulse, and presence of pulse means current, and absence of pulse represents 0 and presence of pulse represents 1. Before going into detail, it is essential to have basic understanding of the number system. And basically we have two types of number system, that is non-positional number system and your positional number. If we talk about non-positional, in the past human being counted on fingers. For counting beyond 10, they use stones and pebbles or sticks. जिससे ये values को indicate करते हैं. And this method of counting uses an additive approach और non-positional number system. जैसे आपका ones, first 1 के लिए होता है 1, 2 i is equals to 2, like this. ये कौन से होता है? ये non-positional number system. If we talk about positional, it varies to write a number in each place. Right? The value depends upon the base of system. Basically, let's learn about 4 common type of positional number. First is decimal number system, जिसका base 10 होता है. ठीक है, 0 to 9 होते हैं, and each decimal represent power of 10. The first is 5 is what? 51. Second 4, 2 is 200, like this 200 plus 40 plus 5. Then we have binary, जिसका base 2 होता है और 0 और 1 इसकी 2 digits होती है. और हर एक जो नंबर है बाइनरी नंबर वो किसको पावर बाय 2 रिप्रेजेंट करता है, राइट। नाउ ऑक्टल नंबर मीन्स बेस 8, 0 to 7, हर ऑक्टल नंबर की जो पावर होगी वो 8 होगी। लाइक फर्स्ट प्लेस 7 is 71, fifth is 8, 8 into 5 तो 57 is the octal is the same of 40 plus 7. हेक्साडेसिमल मीन्स 16, जिसका बेस होता है वो 16 होता है। इसका हम मोस्टली प्रोग्रामिंग और डिजिटल सिस्टम में करते हैं, राइट। इसका बेस 16, सिंबल 0 to 9, लेटर A to F, right? Like A represent 10, B 11 and C 12, D 13. Each place is hexadecimal represented by the power of 16. For example, the first place A is 10, B is 16 into 1. So 1 is equals to same as 16 plus 10, that is 26. Right? Decimal base दिया है, decimal का 10, binary का 2, octal hexa का 16. Now, if you want to convert into one form to another, first is your decimal to binary. Divide the decimal number by value of new base. Record the remainder from step 1 as a rightmost digit of the new base. Divide the quotient of the previous division. Record the remainder from the step 3 as the next digit and repeat step 3 and 4 and afterward it remains from right to left. Binary to decimal conversion. So note down a place value of each digit. Multiply each digit with the place value, add the product to get back the number, and then you have to convert it to decimal equivalent, right? Decimal to octal conversion. Conversion of decimal to octal is similar to the conversion of decimal to binary. So the only difference in the base is the number system. So we have to divide decimal number system. So you have to convert it into octal. Octal में base कितना होगा आपका 10 होगा, तो आप देखते हैं कि आंसर क्या है हमारा 5010, राइट। इसको आपको ऑक्टल इक्विवेलेंट करना है, तो ऑक्टल मींस 8, डेसिमल टू हेक्साडेसिमल, राइट। द ओनली डिफरेंस इज द बेस, इसमें कुछ नहीं है, बस डिफरेंस का है बेस का, ठीक है। जो आपका हेक्साडेसिमल में बेस 16 होता है, राइट, और डेसिमल में कितना होता है 10 होता है। देन वी हैव बाइट एंड द बाइनरी डिजिट। द स्मॉलेस्ट यूनिट इन कंप्यूटर प्रोसेसिंग इज कॉल्ड बिट. It is a unit of data. ये एक unit of data है that can be either of two conditions, 0 and 1. और जो groups of bits होते हैं, what they make storage unit in the computer, जिसको हम characters कहते हैं, bytes कहते हैं, words कहते हैं. Each of 0 and 1 is the following pattern. आप देखते हैं 0 1 0 1 0 0 1 0. ठीक है, ये तो क्या हो गई byte हो गई, और 0 0 क्या हो गया आपका bits हो गया. Then we have byte, that is binary term. The group of 8 bits is called byte. Such groups can be made in binary system. Speaking 28 to 256 bytes are possible and they can represent 256 characters, right? Like 0 to 9, punctuation marks, currency sign, and some special symbols. They all are the what? They all are the different binary systems. Nibble, half a byte. जो half a byte मतलब byte से भी छोटा, वो क्या होता है आपका nibble होता है, ठीक है। ये तो आपकी bit हो गई, और ये वाला byte हो गई, और ये क्या हो गई सारी nibble हो गई, और वो क्या हो गई आपकी byte हो गई, bit nibble byte, ठीक है, half. Right? This is all about in this chapter. We have completed. Hope you understood. Now let's meet in the next class. That's all for today. Thank you.